Hi, welcome back to Oogie's Tech Talks. With me here today is my producer Joe. Say hi, producer Joe.
Hello.
Today we're going to be talking about the decibel scale because we're going to be using that in some of our upcoming conversations. All right, decibel scale is decim, meaning 10, and bell. Now, it's named after Alexander Graham Bell, who developed the scale originally because he was working with deaf people, most famously Helen Keller. He figured out through his studies that in order for a human to hear a change in the volume of an audio signal, it had to go up by 1.29 something times. In order for them to say that the sound was, on average, twice as loud, it had to go up 1.29 times 1.29 times 1.29. Oddly enough, he started looking at this and mapping it out and realized that it was a logarithmic function. And so, to convert something from 1 volt, 10 volts, 20 volts in magnitude into dB is actually quite easy. It's 10 times the logarithm of n, whatever that number is. So, in the case of the number 1, the log of 1 equals 0, because 1 is unity, it's nothing. Oddly enough, the log of 2 equals 3. Well, 0.3 actually. 10 times the log of 4, the log of 8, the log of 10. So the log of 10, in other words, taking 10 and converting that to the decibel scale, it becomes 10. The log of 20 let's go to the log of 100. So if we look at this, the log of 10 is 10, the log of 100 is 20, the log of 1,000 is 30. So instead of huge numbers where you get into the millions or the billions, the log of a billion, 1 times 10 to the 9th, $90. So it becomes more convenient to talk about signals, signal strength, signal power levels, either in the audible world or in the RF and microwave world by using a decibel scale. One of the other fun things about the decibel scale, and we will be using this, is it's generic. What becomes a multiplication here becomes an addition or a subtraction here. So it solves for a couple of problems. If we say that something went up by 3 dB, it doubled its power. If we say that it went up by 10 dB, it multiplied its power by a factor of 10. So if we were to kick something from 90 dBm, decibel milliwatts, to 100 decibel milliwatts, we just increased its power by a factor of 10. We made its power 10 times hotter. Decibels themselves can be used to describe voltage. They can be used to describe the magnitude of a signal. dB is literally nothing more. The decibel scale is nothing more than measuring the rate of change, how much magnitude change something has vertically. Just like frequency, that term is used to measure the rate of change over a second. To measure the magnitude change of something, in other words, it swings from this down to this, up to this, we use the decibel scale. So that gives us the magnitude portion of our question. dB by itself is unitless, and so we typically tend to refer it to something. In the case of RF energy, we refer to it as dB W, which is decibel watts. So how many watts of power? If you've ever had to unscrew a hot light bulb when it goes out, you know what 100 watts feels like. It's pretty hot. So dB watts, what's 100? 20 dBW. Now, in a lot of cases, when you're dealing with very small signals, you're dealing with milliwatts. So we have another scale, decibel milliwatts, which if you divide a watt by if you multiply a watt by 1,000 to convert it to 1,000 milliwatts, you've just upped it by 30 dB. So dBm is always 30 dB higher than dBW. So 100 watts would be 20 dBW, or it would be 50 dBm. So when we start talking about free space path loss, or talking about the transmit power of a panel antenna on, say, a 3G or a 4G tower, we're going to be talking about it in watts. But then, when we start talking about how much power is lost as it gets sent out, we're going to be talking about it in terms of how many dB it lost. And eventually, we can come back and extrapolate the amount of power received by the human body, or received by a cell phone, or received by another antenna, back into watts, but it's going to be microwatts at that point. That's about it. Producer Joe, do you have any questions?
Sounds perfect.
Thank you, sir. Thank you all for being here. Have a great day.